So let's look at shifting the sinusoids in the frequency domain. So if we were to take the function cos omega t, we know that the Laplace transform is s upon s squared plus omega squared. Now if we were to multiply that by e to the sigma 1t, now we've seen that by multiplying by e to the sigma t, that is the effect of shifting along the sigma axis. So when we multiply these two together, it has the effect of taking the cos omega t, which would normally sit here, which would sit here on this I omega axis, and it shifts it along in the sigma axis, so we'll shift it to this new position here. The similar thing will happen with the sine. The sine would normally sit along the I omega axis, and now it can be shifted to a new point given by the value of sigma 1. So whenever we do the Laplace transform of this, what happens is we replace the value of s with the value of s minus sigma 1, and you replace the value of s here with s minus sigma 1, and the same thing happens down in with the sine here as well. The sine would normally be omega upon s squared plus omega squared, so the s gets replaced by s minus sigma 1. So let's go and have a wee look at this in MATLAB. So this example here shifts the cos omega t by minus 1, so our value for sigma is minus 1. So we have our two poles and a 0, but instead of the poles and the 0 sitting in the 0 axis, they're going to be shifted back by minus 1 in the sigma axis. And similarly for the sine function, it's been shifted by sigma equals minus 1, so they're no longer sitting on the 0 axis, they're shifted back by minus 1 in the sigma axis. So let's go look at those live in MATLAB. So again we'll use the L1 function, and we're going to be shifting the cosine, so it's going to be s upon s minus 1 squared plus 1. So that's written as the bracket s dot slash, and then it's s minus 1 dot hat 2 plus 1. Okay, so you have access to that in the resources section anyway. So this will produce the output which we've seen, and we can see there that it's going to be two poles and a 0, and the poles are on the omega axis are going to be at plus and minus 1. So the poles there at plus and minus 1, and also in the sigma axis the pole's going to be shifted to a value there of minus 1. So you can go and try shifting the sine in MATLAB for yourself. So that's all there is for this video, and I'll get you on the next video. Goodbye.